Now let's look at asynchronous programming a little bit more in depth. I'm going to call this fun with futures. First thing we're going to do is import the Dart.io, and let's import async. Let's make a string path to the current directory. And let's give it a file name. Let's print out our file name, and let's make a new file. We're going to be working with a future. So what is a future? We've worked with it before a little bit, but we don't really understand it. So a future is, well, a promise. Notice how it is a generic type. So we need to give it a, in this case, a random access file. And we're going to say f equal file.open. And this is how you can tell what you need here. In the file open, you can see we have to give it a mode, and it's giving us a future random access file. So what does the future really do? Well, the future says you're going to get a specific type of object, in this case a random access file, but you're not going to get it right away because it's asynchronous. You're going to have to wait for it. So we're going to call open, and we're going to call mode file mode.append because we just want to append to the file. Now comes the interesting bit. We're going to say f.then. That's how you know we're in asynchronous programming right here. Random access file, and just call it RAF. And let's fix that. All right, now that we have our random access file through asynchronous, we need to do something with that. Let's say print. Now we're going to say random access file, and we're going to write a string. Notice how there's the string sync and string. Synchronous is, well, synchronous programming. We want to work with asynchronous. So we're going to write string, and we're going to get a future back from that. Now, when we say write string, we need to give it a value. But we also want to be able to do something when it's done. So we're going to say then. And let's do something with this. But we also want to be able to catch errors in case something happened. Remember, asynchronous programming can be a little tricky, and you may not always catch your errors. So we want to basically have the try-catch block here, but we want to do it asynchronously. So what we're going to do is we're going to go down here, and we're going to say catch error. Notice how it has a function on error. And we're just going to simply give it an anonymous function, and we're going to print out an error occurred. But we also want the finally part of this. So let's go here, and let's say finally. Or I'm sorry, when complete. Got a little ahead of myself there. That also needs a function. In this case, we just want to close it. Now, notice how close is also an asynchronous call. You can say then, but we really don't care. We just want to close it and move on with life. All right, let's expand our project here, and we're going to see this file be created. You can see how it says appending, and then we have this, but immediately jumps to the end. That's why I put these stars here. But then it says the file's been opened, the file's been appended. So what is going on here? It goes from here immediately down to here, but then it looks like it executes this code. That is interesting. You can see there's our file and there's the data, so everything worked as expected. This is the complication of working with futures. What's really going on here is this executes. Then, because this is executing in a synchronous mode, you can tell because it's working with a future, it immediately handles execution of the program back over here, so it jumps back to line 11. And then, off to the side in memory, all of the future code is running. So this code is running effectively at the same time. Now, to keep things simple, we can't have all of this gibberish printing out at the same time or it'll be unreadable text. That's why it's ordered in a specific way. Pretty simple, but pretty complex. Be careful when working with futures. Always use the then keyword, and just understand that the catch error and when complete is equivalent to the try catch block